Hello guys, this is Prime Concept. Now we are still looking at refraction at plane surfaces, but in this video we want to consider the idea of total internal reflection. Now in my previous video when we started optics, we started by studying reflection under optics, and then I mentioned that whenever you incident light on a surface, three things are capable of happening to that light. One of the things that can happen to light that is incident on a surface is reflection, which we considered in that part. Another thing that can happen to light is refraction, which is the subject of this. Then the third thing that can happen to light is absorption, which is what we would study under thermal physics. Now, we are looking at the idea of total internal reflection. Now, whenever you are incidenting light from one surface to another, you always experience at least refraction and reflection, right? You experience these things. But total internal reflection would only occur under two conditions. So before we explain what total internal reflection is, we want to first mention the conditions for total internal reflection to occur, so that under those conditions we can now see what total internal reflection would be. So what are the conditions for this to happen? Conditions. There are two conditions for total internal reflection to occur. Number one condition is that light should be incident from a denser medium to a less dense. So that is one condition. So your light must be coming from a medium that is denser than traveling to the less dense medium. If you travel from a less dense to a denser, you can never experience the phenomenon of total internal reflection. So it means that this is the first condition. Your first medium should be denser than your second medium, right? Now, number two condition for total internal reflection to occur is that your incident angle should be greater than your critical angle. The incident angle should be greater than your what? Critical angle. So again, some students may ask that we don't understand what critical angle is. So how do you then understand total internal reflection? So what I will do now is to first explain the idea of critical angle. Since you have known that these are two conditions for total internal reflection, we want to explore what critical angle is. When you properly understand what critical angle is, we'll then come back and explain what total internal reflection is. So I believe this will be very clear to you. Now, all this critical angle. Now, critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense medium is 90 degrees. I take it again, try to put it down. Critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense medium is what? 90 degrees. So what it means is that if I have a situation like this is dense medium, denser, and this is less dense medium, less dense. Now if I incident light, say this is my angle of incidence, I would get, because I'm coming from a denser medium to a less dense medium. You remember what we said earlier, when you're moving from a denser medium to less dense medium, your refracted rays usually are away from your normal. The refracted rays usually are away. Now what will happen in this case is, if we decide to keep increasing this our angle of incidence, we increase our angle of incidence to this point, you increase. So when we keep increasing our angle of incidence, our refracted ray will be moving towards the plane surface, right? So it will be moving away from the normal, trying to align with this surface. So as we keep increasing this, we'll get to a point where this refracted ray would now align with our surface. So you then have something like this. You then have something like this. The refracted ray will now align. This will now be your refracted ray. So if your refracted ray then aligns with your plane surface, it means, if you watch, it means that your refracted angle in this case would now become what? 90 degree. Now when your refracted angle becomes 90 degree, this angle is no longer called angle of incidence. The angle that gives you 90 degree here is no longer called angle of incidence. This angle will now be called critical angle. So therefore, what is critical angle? Critical angle is the angle of incidence, which you can see when the angle of refraction is what? 90 degree. So that is critical angle. Now, somebody may ask, can we find the value of critical angle for a particular pair of media? Yes, we can do that. So how do we do it? That is the next thing I want to do. I want to show you how you can always calculate for the critical angle, right? Now, if we follow Snell's law. Remember, we are moving from a denser medium to less dense. According to Snell's law, you have that sine I over sine R is going to give us what? N. And this formula is true when you are moving from a less dense medium to a dense medium. Then you would have this. But if you are moving from a denser medium to a less dense medium, so what it means is that you're going to have this sine I over sine R is going to be 1 over n. So it's going to be the inverse of your refractive index. Remember, refractive index is actually relative. So I don't want to bring that idea. So just know that since we are moving from a denser medium to a less dense medium, it means you have to invert your refractive index, right? So that is what Snell's law is saying. So if I do in this case, I know that when my angle of refraction is 90, when R becomes equal to 90 degree, then I is now called what? Critical angle. So I'm going to substitute this here. So for I, I'm going to substitute that with what? C. So I would have sine C all over what now? Sine 90 degree equals what now? 1 divided by n. So what is sine 90? Sine 90 is what? 1. So if I do that, I'm eventually going to have that sine C, which is critical angle, over 1, still sine C, is going to be equal to what? 1 over n. So this is the formula we can always use to find critical angle. Sine C equals 1 over what? Refractive index. So with this, you can always find your critical angle. Now, since you understand what critical angle is, we can now go back and explain total internal what? Reflection. Now, remember I gave 2 conditions for total internal reflection to occur. Condition 1 is that light should travel from a denser medium to a less dense medium. Condition 2 is that your angle of incidence should be greater than the critical angle. Now, if you watch, you have increased your incidence angle so that your refracted ray is now lying on this surface. You can still decide to increase this further. When you now increase your incident ray further so that it becomes greater than C, if this angle now I is greater than C, this ray will no longer lie on this surface. Every part of this ray will do what now? Will travel and return back to the same surface from which it was incident. So this phenomenon is what we know as what? Total internal reflection. So in a simple term, What is total internal reflection? Total internal reflection is the bouncing back of all the incident ray to the same medium from which it was incident, so long as light is traveling from a denser medium to what? A less dense medium, and this would occur when the angle of incidence becomes greater than what? The critical angle. So that is what we know as total internal reflection. So I believe this is very clear to you. So take home the concept of total internal reflection, which occurs under two conditions, and take note of the formula for finding critical angle, which is simply sine C equals 1 over n. You can find your critical angle. I believe this whole concept is very clear to you. If you have enjoyed my video up till this point, please do well to like this video. If you are not yet subscribed to my channel, do well to hit the subscribe button. Subscription is free, and do well to share my videos with your friends so that they can also benefit. And I really appreciate those of you that have been supporting and consistently watching my videos. Remember, this is Prime Concept. Thank you.